Okay, good evening everyone. So I hope my voice is audible and my screen is also visible. Okay. So actually, this is our syllabus for the first year, second semester outcome based laboratory task. So this is regarding the subject Basics Electronics Laboratory. Subject code is 18EC 208. Okay. So I hope on Monday session you have got some idea about how to design this particular task. Okay, how to complete the first task. Sanay sir has completed, I hope. So in continuation with, I'm going to complete the third task. Okay, so actually it is planned a session in the morning, so unfortunately it was shifted to the another day, so that's why it was like this. So anyhow, I'm going to talk about the task number 3, that is a 2-channel DC gear motor driver using Mosfet. Okay, and this will cover the experiment number 7 and 8. So the experiment number 7 and 8 will be here, okay, listed here. So first of all, you will be started with our current and voltage law. So whatever theory that you have studied, you can able to do it with the laboratories as well. Okay, so you are going to cross verify whether these theorems will be working or not in real time. Okay, so that is why this list of experiments were given. So first one will be current and voltage law and circuit theorem and half wave rectifier. Then finally you will be designing an power supply unit for the any electronics gadgets. So that is your task number 1. And in the second task, you are going to design an amplifier based upon the transistor BJT. So this is a very basic transistor that you know. NP and PNP are the two categories. So based on that, we are going to design one wave shaping circuit. And what we are going to discuss today is about the MOSFET, the advanced version of the transistor. Okay, you know, in electronics, all the devices will be manufactured by using the transistor, and the advanced version of the transistor will be the MOSFET, metal oxide semiconductor field effect transistor. It will be the short form of MOSFET. So in MOSFET, what is the advantage we find over this BJT, in the sense here everything will be 100% accurate. Okay, for example, if you take two types of MOSFET like NMOS and PMOS, we will be getting the accurate output as expected. For example, if you expect 5 voltage in the output side, that you can get it from this MOSFET device. But in the case of your BJT, if you are expecting something like 5 voltage, it will give you 4.7 voltage or 5.2. So you will get a plus or minus 0.3 error. And also instead of getting 0 voltage, it will give you something like 0.3 or 0.5 likewise. Okay, so that error, if you want to overcome, then you have to go with this MOSFET devices. So I'll tell you how to design this MOSFET devices and what is the use of this MOSFET device. Okay, usually the transistor will be used for switching and amplification purpose. Okay, so the amplification will be carried out by the sir, Suresh sir, by tomorrow. So today I will tell you how does this MOSFET will be acting like a switch. Okay, and in continuation with, we are going to design a H bridge circuit called as a motor driver circuitry for driving any high voltage motors with the help of some small voltage controllers like Arduino or your Raspberry Pi kind of things. Okay, so whatever it may be your controller, if you want to interface with any particular motor, especially for the vehicles or for your line follower robots or any other robots, if you want to interface with the controller, definitely you would need a driver circuit. Okay, so driver is a interfacing circuit which will convert the low voltage into a, which will operate the high voltage device by using the low voltage input. Okay, say for example, the Arduino will give you the voltage range of 0 to 3.3 voltage, but if you want to drive a vehicle or a motor or a line follower robot, in the sense at least a 12 voltage is required. So if you directly connect the 12 voltage to your Arduino, then your entire system will be damaged, your controller will be damaged. So in order to provide that, we are in need of an interfacing circuitry. So that is where this hedge bridge circuit comes into act. Okay, so that circuit we are going to design. So for that, we are going to use an online tool, because you are all in your home. You can be you can use this particular site. Okay, so Tinkercad, I hope the SAR has introduced. Okay, Tinkercad. So this is the tool name or online site name. So if you type in Google as Tinkercad, then you will be directed towards this particular website. So you click onto this. At any point of time, if you have any queries, you please stop me and you can raise your question. Either you may unmute your mic or you may post your queries in the chat box, so that I'll be responding to that also. Okay. Yes, hope. Give me a moment. I'll take a screenshot of today's class. If I'm going fast also, you please stop me so that I'll repeat it again. So this is where you have to work on with. Okay. So after the today's class is over, all of you please try to complete the tasks. And if you have any queries also, you may ask me through WhatsApp, or you can send an email, or you can chat, contact me through call also. Okay. So whatever you wish, you can call. So first of all, you have to create an account. So for that, you can click on to the join now. Since I have already created an account, I'm just going with the sign in. Okay. So this is an online tool that you know very well. Via the Gmail account, you can easily get into this forum online tool. And this is a very good simulator tool that you can feel like you are working inside the laboratory physically. Okay, so whatever the devices like CRO, RPS, or the voltmeters, or any multimeters, or any breadboard kind of things will be available inside this particular uh, online tool. So I'm just logging via my Gmail account one side, and with the same I'll be signing in with this Tinkercad. Okay, either you can give it here all the credentials and an email, sorry, password while creating an account in this Tinkercad, or otherwise you can directly go with your Google sign in option. I'm going with the Google sign in option. So click on to that, then it will redirect you, and it will ask permission regarding your email facilities. It may use your some of the credentials from your email, so you have to be very careful. So most of the times your personal email IDs should not be given. And once if you have logged in, then your dashboard will be looking like this. And here are the some of the projects that I have created earlier. So that will be listed under this project category. And these were the circuits that I have worked previously. Okay, So only for your class, I have listed some of the circuits. So I'll go with one by one. So first circuit will be the use of MOSFET. Okay. So as I said before, the MOSFET can be used for two purpose, or any transistor can be used for two purpose. One will be the switching and other will be for amplification. Okay. So we shall see how does this will be working like a switch. So I have created this design already. So I just going with this tinker this option. Either I can go with simulation or I can use this model for re-editing. So there were three terminals available in typical switch, MOSFET switch. So this is how a typical diagram will be looking like. Okay, our circuit is ready. So here we can see the MOSFET switch. Okay, so if you scroll your mouse button, you can able to zoom in. Okay, so here you can see the NMOS. Okay, so and on the other side we have the PMOS. So these are all the two different types of MOSFETs available. So what is the difference if you ask? The NMOS will be always in off mode. Okay, so by default it will be in off mode. Only if you energize this particular NMOS, it will come into act. Okay, but in the case of PMOS, it will be in off mode by default. And if you are energizing this, it will go into sorry, by default it will be in on mode, and if you are energizing this, then it will go into off mode. Okay, reverse manner. Okay, so if you want to work with the forward logic, then you have to use the NMOS. But what is the advantage of using NMOS? In the sense, it will give you the perfect logic zero. If you expect zero voltage, suddenly it will give you exact zero voltage by using this NMOS category. But in the case of PMOS, it will give you exactly 5 voltage. Okay, in the vice versa case, it will be poor. For example, NMOS, it will be giving perfect zero voltage, but instead of 5 voltage, it will give you just 4.7. Okay, a little lower voltage alone it will give you. That is a disadvantage available in the NMOS. But in the case of your PMOS, it won't give you zero voltage exactly. It will give you something like 0.3 voltage. Okay, so one side it is good and other side it is bad. Okay, so that's why we are going to use both the transistors in circuitries. For example, if you expert zero voltage perfectly zero and 5 voltage perfectly 5, in the sense combinedly you have to use. Okay, so PMOS is always good for high voltage, and high voltage in the sense logic high, and NMOS is always good for logic low value. Okay, so combinedly it will be called as an CMOS circuitry, complementary MOSFET circuitry. Whatever the circuit you are designed with, both the transistor will be called as a CMOS transistor. So here we are going to see how does a single NMOS will be working like. Okay, so there are three terminals available. I hope so you can able to see. The names are gate, drain, and the source. Okay, so gate is the input terminal, and the source is your ground terminal most probably. Okay, and the drain terminal is your output terminal. Okay, so you might have seen in the theory classes. Okay, so drain terminal will be always used to connect with your output, and your gate terminal will be energized via some switches or any biasing voltages. Okay, and your most probably the ground will be the source terminal. Okay, so in that situation we are going to ground it. So I have taken one device called voltage power supply. Okay, so these devices you can find it here. So if you click onto this component column and if you click all, then you can able to list out all the components. So it will begin with the general components like resistor, capacitors, switches, and your potentiometer, your sensors. Okay, and then it will list out some of the output devices like light, LED, and your DC motor kind of actuators, and finally it will come with the batteries. Okay, so these are all the available components inside your Tinkercad tool. Okay, so from this only I have taken. So here is your instruments like power supply available. So this is your power supply. Once if you energize, you can able to see, and there is a function generator, oscilloscope, and multimeter. Whatever you wish to do with the laboratory, those tools were available here. Okay, so that's a specialty of this particular tool. Even for your circuit theory concept, you can able to use this tool for verifying all your theorems. Okay, so now I have used the voltage supply. So what is the use of voltage supply in the sense? It will be giving you a certain voltage. For example, this bulb will be glowing with the help of 12 voltage in the sense, then that can be used. Okay, so for example, I have taken a positive and negative terminal, and positive terminal is connected with my gate terminal. Okay, so it means that if I energize this particular NMOS, then there will be a conduction. Okay, well, so you know very well that the current will flow only when the circuit is closed, right? So you see this bulb connection. So for this bulb, there is a line starting from the positive line to the one end of the bulb, and other end of the bulb must be connected with the ground connection, right? So, but instead it is given with the drain terminal. So, you know, the drain will be the output terminal of this particular MOSFET, and the S terminal, that is your source terminal, is already grounded. So when do you connect this drain and source, then the bulb will be getting energized and it will be glowing. Okay, and if not, then it will be in off mode. Okay, so let us check that. So I'm clicking onto the start simulation. Now the voltage rate is 16 voltage. 12 voltage is more than sufficient, but if you increase, then you will get a brighter light. Okay, so I have set the 12 voltage. Now if I push this button, then light will glow. Okay, if I keep on pushing this particular button, it will glow because it is a push button. Until I'm keeping a finger onto this button, it will glow. If I take out my finger, it will be in off mode. Okay, so you can understood the concept, I hope. So what it is doing actually, in the sense, it will be giving the bias voltage to the gate terminal. Actually here bias terminal is connected with my switch. Okay, in order to avoid the high voltage current and high voltage and high current rating, I'm just using 1 kilo ohm of resistance. Okay, so that the current flow will be milliamps. If not, then current flow will be in amps, so that may damage my circuitry. So I'm using one resistor here, and if I press this particular button, what happens? The biasing voltage will get into this gate terminal, so that the transistor will be turned on. So if the transistor is turned on, my light will glow. Okay, so like this. So this will be acting like a switch. Now a single NMOS can be used as a switch. Similarly, you can also use your PMOS device as a switch. Okay, so here also I have used one voltage source, and I have connected my positive terminal of the voltage to the source terminal and negative terminal to the gate terminal. Why? Because it is a negative operating voltage device. As I said before, if you leave it as a 0 voltage, it will be in on condition. If you give a high voltage, it will turned off. Okay, so that's why I have connected reversely. Okay, so here negative is connected to your gate terminal and positive is connected to my source terminal. So that is the difference between the NMOS and PMOS. It will work reversely. But whenever I want to press the button and make a LED to glow, in the sense, I have to connect in the reverse manner. So that's why I have done like this. So now let us see what it is doing. So if I keep on pressing this particular button, it is glowing. Okay, so you may ask, why sir it is not working in reverse manner? In the sense, because I have connected the terminals in the reverse manner. See here, gate terminal is connected to the negative terminal of my voltage source, and the source terminal is connected with my positive terminal of my voltage source. Again, between the gate and the source, I have used 1 kilo ohm of resistance to ensure there is a milliamps of current flow. Okay, if not, the current flow will be heavier and it may damage the circuit. Okay, so this is an example for making my MOSFET as a switch category. Okay, and for the amplification category, I will explain by tomorrow's class. Okay, with that, I'm just going to the second part of the class today. So the second part is about a DC motor drive. Okay, so this is the driver circuitry actually. Those who are doing line follower robot or any kind of robotic kind of application might have come across this particular board. Okay, so in addition with your Arduino, you should add this particular board so that it will drive a motor with a capacity of 12 voltage rating. Okay, about 12 voltage also you can able to operate, but depending upon the board specifications. Okay, and this will be comes in the IC version called L293 or L298 motor driver circuitry. Okay, so driver in the sense it is an interfacing circuit, interfacing between your motor and to the controller. Okay, and it will do it will also be called as an H-bridge circuitry. Okay, so this is another name. So what it will do in the sense, based upon the input voltages, like square waveform, like input voltage, if you give it to that particular board, then during that time alone it will operate the motor, and rest of the time it will be switch off your motor. Okay, so that you can get an very small movements in your robots. You might have seen line follower robot, which will take a very small movements. Okay, and if it wants to run faster, then we have to give the continuous signals like 12 voltage in the continuous manner. So in this manner, if you give, it will give you a continuous rotation. But if you give like a small pulses of voltage to that particular interfacing board, then it will make a small steps. Okay, so that is how it will work. Now this is how your H-bridge circuit will be designed. Okay, so actually you want to drive the motor in both the directions, because in the robotic movements you have to take your foot front and back, as well as the arms in the front side and in the back side. And in the case of your line follower robot, you may need to take a left turn or right turn or front or back likewise. Okay, so you need to rotate a single motor in both the directions, both in clockwise and in anti-clockwise direction. So for this, what we need to do is we have to energize that particular motor in with two different polarities. For example, if you take a motor in this particular category, I'll show you what it will do actually. So if you want to go to the home button, you can click onto this Tinkercad icon here, so that it will take you to the front page or the home page of your tool. And then click onto the circuits. So predefined circuits were available here. And then Mosfet circuitries. Okay. So here I have already added an motor and H-bridge circuitries, but I will explain what is a motor alone now. Since it is an online tool, it will take some time, like 30 seconds to 1 minute also, depending upon your internet speed as well as your RAM size. But don't worry, it will give you the exact answer or what you are looking in your laboratories. Okay. Even for all your product demonstration, you can use this particular tool. So here there are different motors available. So I'm interested in the DC motor. So if you search the DC motor, that is available. So you can take this motor, and for energizing this motor, you need a 9 voltage battery. Even less than 9 voltage battery is also available. You can add it together. Okay, so two WSL battery or three WSL batteries if you are using, then you can able to get 9 voltage, right? So 2 or 3 volt devices, if you are adding seriously, then you will be getting the required voltage. So for rotating the component, you can press on to the R button so that it will be rotating. Okay, so this is my motor and this is my battery. So motor positive terminal will be shown red in color. Okay, I hope so. The screen is showing red in color and this side is black. Okay, so red color we need to connect with the red color of my battery. If you take your cursor near to this particular battery, it will show one negative and the other positive. Okay, so now I need to connect my positive to the positive and negative to the negative. Okay, so if I connect and if I start simulate, it will rotate with a predefined speed. Okay, because the voltage rating is 9 voltage, it will be rotating in this speed. Okay, so RPM is 17,568 RPM, rotations per minute. And if I reverse, okay, for example, if I want to rotate in the reverse direction, what I have to do is I need to change the polarities. Okay, so positive to negative and negative to positive. So here I have connected the black terminal to the red terminal and red terminal to the black. Okay, so reverse manner I have connected. Now if I stimulate, I will get an reverse polarity. Okay, so minus 17,568 RPM. So in this manner I can get an reverse rotation. Okay, so what difficulty that we are facing in this in this circuitry is that every time we need to disconnect and connect our source in two different method. Okay, so for positive forward rotation you have to connect positive to positive, negative to negative. For reverse rotation, vice versa connection you have to make. So this cannot be possible always. In the case of uh, your line follower robot or any kind of robot arm movement, then you cannot expect always this can be done, because you are not going to handle that particular robot in your physical hand. Okay, so it is remotely operated. So what you can do is that instead of switching like this with a manual wiring, I'm going to use this particular H bridge circuitry. Okay, the main aim of this H bridge circuitry is to provide the voltage power supply in both the directions. Whenever it is required, it will be controlled accordingly. Okay, say for example, for one particular moment of time it will be going in the positive direction, and on the other particular moment of time it will be going in the negative direction, anti-clockwise direction. Okay, so for the clockwise direction movement, I need to energize this particular switch. Okay, so I can able to see sorry, you can able to see this particular switch has to be energized, and this switch as well. So if these two switches are closed, okay, so the left hand side switch at the top and the right hand side switch at the bottom, if both are energized, then this side will be positive. Okay, left side will be positive and the right side will be negative, so that it will be in clockwise direction. Okay, so left side top, right side bottom switches are closed, in the sense it will be clockwise, and vice versa. So right side top and left side bottom switches are closed, in the sense it will be rotating in the anti-clockwise direction. So during this time the current will flow from VCC to the motor, and from this direction it will be grounded. Okay, so that will also be shown below, I hope. Sorry, I have taken it as a image. Oh, sorry, I lost that. Okay, anyhow, you may have an idea. So there are many videos available, but that will take a long time to play. So that's why I'm going with this method. So for the positive direction, it will be energizing this particular transistor and the right side transistor. Okay, transistor 1 and 4 will be energized. And for the left side movement, that is in the anti-clockwise direction movement, it will be energizing the transistor number 3 and the transistor number 2. So this is how it will be operating your MOSFET transistors. Okay, and this MOSFET transistor, if you are designing in your Tinkercad, then you can able to work with the motor. You can able to switch your motor in both the directions. Okay, so I hope the screen is clear. Okay, so these are all the four transistors: Q1, 2, 3, and 4. Okay, if you want to make the motor rotate in clockwise direction, Q1 and 4 must be in on condition. And if you want to rotate in the reverse direction, Q3 and Q2 must be turned on, and the rest of the two must be turned off. So as I said before, there are two different transistors will be used. So MOSFET transistors, upper side you will be having an P MOSFET, and at the lower side you will be having N MOSFET. Why? Because N MOSFET is good for conducting the ground value, that is logic 0 value, and P MOS will be good for conducting your high voltage value. Okay, so logic 1 value. So that's why we are using both the transistors together. So this type of circuitry is called as an CMOS circuitry. Okay, complementary metal oxide semiconductor circuitry, field effect transistor. Okay, so that category will be available. So that's why we are using this H-bridge circuit for operating your DC motor. So for any doubt, if you have any queries, you may ask. Any doubt so far? And for ensuring your attendance, please all of you post your roll number alone, okay, not the name, roll number alone in the chat box, so that I'll account it as a attendance for this class. Only one time you have to post, okay? So post your roll number alone in the chat box, so that I'll consider that one as an attendance. So now this particular H-bridge circuitry, we need to design it with the help of a MOSFET device. So that is where this particular IC come into picture. Okay. So this board, this driver board. So actually we have the connection like this. So the physical connection will be something looking like this. So that particular connection, if you don't want to confuse in future, and for getting the more reliability while designing your product, it will be coming in this particular board like structure. Already it is a embedded board, so that you can easily use it with along with your controllers. Okay, and you have to simply give the power supply to this particular board. So we know very well, without biasing, no electronic circuits will work. Even your mobile phone or your remote controller, whatever electronic circuit, if you want to operate, it must be energized. Okay, so even though remote control is a perfect embedded electronic device, in order to send a signal or control signal, you need to put a battery, right? So, and also for your mobile phone, if it wants to work, we need a battery. Likewise, this circuitry is also need a battery voltage. Okay, so for that we are giving the power supply here, and there will be an onboard regulator which will convert that voltage into a 5 voltage rating. Okay, even if you give a high voltage, that will be converted into a 5 voltage, because we are going to operate for 12 voltage on the one side, and on the other side your input will be like 3.3 voltage. Okay, and if you see how much voltage will be dropped across this particular circuitry, in the sense about it is 2 voltage. For example, if you give 2 voltage, no voltage will be supplied at the output terminal. If you give 4 voltage, 2 will be subtracted, you will get 2. If you give 7 voltage, 2 will be subtracted again, you will get 5 voltage. Likewise, if you give 12 voltage at the input, then you will be expecting maximum of 10 voltage. So at least 2 voltage will be the drop voltage required for your circuitry, because the MOSFET transistor needs to be biased. It will be consuming certain voltages. Okay, and that's it. So the connections are over. Now we need to connect this particular board with your controller, so that it will be operating your motor. Okay, so you can give the control in both the sides, like out. So this input 1 terminal, input 1 and 2, and input 3 and 4 terminal, you can give the input connection, and you can control 2 motors with the help of this particular board. So one on the output side 1 and 2, and on the ninth pin output 3 and 4. Okay, so that is how this will be working, and in real time. Okay, so how does your real time circuit will be working will be shown here. So you'll be given with one controller. Definitely we need to direct the motor, or the direct the vehicle with the help of some controllers. So here it will be taken as an Arduino. So in this case, Arduino will give you the voltage rating of 0 to 3.3 voltage to this particular board. So we know very well this particular 2 motors will never run with the 3.3 voltage. It requires at least above 10 voltage, at least 9 voltage or above. Okay, so then only the motors will start rotating. So in order to convert this 9 volt 3.3 voltage into a 9 or 10 12 voltage, then we are using this driver circuitry, H bridge driver circuitry or L293 driver circuitry. So we are giving certain voltage like 0 to 3.3 voltage. Whenever we are giving 0 voltage, it won't perform anything. If you give 3.3 voltage, it will rotate. And in the reverse manner, for this particular board, if you want to operate in a reverse direction, then you have to give like 3.3 and 0. So likewise, we can continuously change the values, right? So here it will be like low and high will be continuously sent in any particular pin to turn off the motor. And if you want to turn on the motor, high will be sent. Okay. So low, high, low, high. Likewise, they will be alternatively sending. It means that it will rotate for 2 seconds in forward direction and 2 seconds in the reverse direction. Likewise, it will be done. And for specific kind of applications, we can control the switchings. Okay, so either for 5 seconds we can make turn it on the forward direction and 2 seconds for the reverse direction, depending upon our need. Okay, so whatever it may be your path, or depending upon the situation, we can able to change. But anyhow, we are going to send any two voltage like low and high. Actually, in the case of your Arduino, it is 3.3 voltage and 0 voltage. Low means 0 voltage, 3.3 means high voltage. That is for your Arduino. But that 3.3 voltage will be converted as a 12 voltage output for this particular motors by using this L293 H bridge. Okay, so I hope this H bridge concept is understood. So with that, I'm going with this transistor construction. Okay, so as you have seen, there are two different transistors used. So here also I'm using two transistors. One is PMOS and another one is NMOS. So NMOS give you perfect 0, PMOS give you perfect high voltage, logic 1. Okay. So for your better understanding, I have used two different batteries. So this left side 9 voltage battery is used for driving this motor. Okay, as I said before, this DC motor requires at least 9 voltage or above. If I use 12 voltage, 12 voltage in the sense the rotation of this motor is very, very fast. So I cannot able to display like whether it is rotating forward direction or in reverse direction. So that's why I used 9 voltage here. But if you wish, you can use 12 voltage as well. Okay, so this is the motor and this is your battery for energizing this particular motor alone. And next one, the biasing voltage for my transistors. Okay, so here I have used a AA cell battery. Okay, so if I click onto this battery, you can able to see the type. It is a AA cell battery type. If I wish to add a AAA cell battery also, you can have a chance. Okay, so this is AAA. So I'm just using now AA. If you want to make the entire circuit visible, you can click onto this particular icon, so that entire circuit will be visible. Now I have clicked on to this battery. So there are two batteries I have added. Okay, if I make it as a single battery, it will supply 1.5 voltage, but I need at least higher voltage, right? So 2 or 3 voltage if I give, it would be better to operate my PMOS device, because it is dropping 2 voltage at the internally. Okay, so if I give above 2 voltage only, it will work perfect. So I'm controlling this PMOS and NMOS with the help of 3 voltage at least. Okay, above 3 voltage also you can give. And I have added a switch here. So in the previous circuit, I have used a microcontroller, but instead I have added a manual switch here. Let us assume this is your joystick switch. If you press on to this switch on the upper side, it will rotate in the clockwise. And if you make it as a downside, then it will be in the reverse direction. So likewise, I have designed the circuit because I thought you may not be much aware about the Arduino coding. So that's why I have gone only with the physical electronics component connection. Okay, and you might be knowing about this breadboard. So in these areas, it is vertically connected. There will be a vertical plate behind, so that all these lines will be considered as a single point. And at the bottom, all these horizontal lines will be considered as a single point. Whatever the component you connect across this particular line will be joined together. Okay, so that is the reason why we are adding. And here I have added my negative terminal of the battery. I hope it is visible. The black color shows the negative terminal of my battery. Okay, but if any circuit wants to be work perfectly, then all the ground terminals must be connected together, and also the circuit must be closed. If not, the current won't flow, right? So here I have given the 9 voltage to the top portion. So here this is called as a power rail also. Okay, so there is a symbol called plus Okay, so this represents positive power rail and bottom represents negative power rail. So for the positive power rail, I have connected my 9 voltage. So what happens? This 9 voltage is supplied with my PMOS. As I said before, PMOS is good for uh, connect conducting your high voltage, that is logic 1. So here in this case it is 9 voltage. So if you want to make this 9 voltage to be passed to your motor, then you have to connect this 9 voltage to the PMOS of the source. Okay, so I have connected PMOS source to the 9 voltage, and drain terminal will be connected to the motor terminal. So for that only I have used different color. Okay, so red terminal shows the 9 voltage is coming in. Okay, and it is going via the brown color terminal. Okay, so brown color line will be taking this voltage to the motor. And similarly for this NMOS at the bottom, the drain terminal is connected with my motor. Okay, so as I said before, there are two transistors required because it is going to connect, sorry, it is going to take 5 voltage, that is logic 1, as well as low voltage logic 0. Okay, so both the things it is going to take. So I need to use PMOS for taking the high voltage and this NMOS for conducting the 0 voltage or the ground, low voltage. Okay, so for this my source is connected with my ground terminal. Okay, so via this NMOS 0 voltage will go, and via this PMOS 5 voltage will go. Okay, now I hope you understood the one half. So this will be connected with my positive terminal of the motor, and on the other side again there is a PMOS and NMOS. So this PMOS is again connected with the 9 voltage. So as I said before, this is a power rail carrying 5 voltage. So this 5 voltage is coming into this source terminal, and here at the bottom NMOS transistor it is connected with one ground terminal. Okay, so ground terminal, so it is a 0 voltage. So the 0 is going via this green color line. Okay, via this NMOS the 0 voltage will be propagated to my motor, and via this PMOS above upper side PMOS it will carry the 9 voltage to my motor. Okay, so I hope the screen is visible and you can understand. Okay, so somehow you will be passing the 9 voltage as well as the ground voltage to your motor. Okay, so for switching between the switching between the 9 voltage and 0 voltage, we are using this H bridge circuitry. Okay, so since we are connecting in the breadboard, the connection must be in this nature. Okay, so as I have given, there are 4 switches in that particular simulator, like here. Okay, just a moment, I'll open. Yeah, so like here there are 4 transistors available. So left side top there is an PMOS, and right side top there is an PMOS, and in the both the side bottom you have NMOS. So the same circuitry will be designed here. So there are 2 PMOSs and there are 2 NMOSs. So both bottom transistors will conduct 0 voltage, both top transistors will conduct 9 voltage, so that the motor will rotate in one direction. Okay, so when it is rotating in the clockwise direction, actually the positive terminal needs a positive supply, right? So your right side PMOS transistor must be turned on so that it will carry this 9 voltage and it will supply to the motor. And on the reverse direction, your this left hand side PMOS need to connect with the motor. So it will carry the voltage in the negative terminal of the motor, so it will rotate in the reverse direction. And I have connected this biasing voltage to my switch. So this is the 3 terminal slider switch. Okay, so it is called as a slide switch. So inside this switch we have 3 terminals. So first terminal, the middle terminal, I'm going to connect with my biasing voltage. Okay, I can switch this voltage to the upper direction or a downward direction depending upon the position of this switch. Okay, so I can, if I click onto the downside, the switch will come into the downside switch position. If I click onto the upper side, the switch will connect to the both higher end and the middle end of the uh, switch into contact. Okay, so that the voltage will be propagated here. Okay, so anyhow in one direction alone the current will flow, so only in one direction the motor will rotate. This is just for switching between the forward and reverse direction. And this battery, AACell battery, is used for energizing this transistor, and this 9 voltage battery is used for rotating this particular motor. Okay, now we will see the overall simulation. I'm just clicking onto the start simulation. So initially the switch was in the upper portion. So the motor was rotated in the forward direction with a RPM of 1155 revolutions per minute RPM. Okay, it is in the forward direction. Now if I change the switch position, it will be in the reverse direction. You can see the rotation speed is minus 1155 RPM. Okay, so but in the physical picture it may be in the clockwise direction. You may wonder, okay, why it is? Because the right side terminal is the positive. Okay, so see here, the for this motor, right side terminal is positive and left side terminal is negative. So it is in the reverse direction, it is moving from left to right. So suppose if I change the direction, you can able to see. Now you see the motor rotating direction is from the positive to the negative. See, in this direction, from the positive to the negative. So that's why it is showing it as a positive. I hope it is visible and it's clear. And you can able to see the voltage as well. Okay, so the across this particular motor, how much voltage is dropped. Okay, it is about 578 millivoltage. For that only I have used two resistors here. If I'm not using these two resistors, then it will give you the heavy current to the motor and it will rotate in a very high speed, as well as the voltage rating is also very high. Okay, so if I switch to the negative direction, then it will be minus 578, positive direction plus 578. Okay, only the sign matters. Okay, so it will go in the positive direction or in the reverse direction. This is called H bridge. Okay, it is used to drive a motor, okay, in both the direction. The applications are like your robotics. Okay, so if it is a line follower robot or manual robot which is operating in any remote location, can be used with this particular circuitry. Okay, so here in I'm used one manual switch, but in real time you are going to use a controller. Okay, so that controller will give you a low voltage like 0 and 3.3 voltage. In order to operate a high voltage device with the help of low voltage device, we need a interfacing circuitry called driver. So that driver name is H bridge. Since it is looking like a H in shape, so it is H in shape, right? So that's why it is called as an H bridge circuitry. It's all about my side. If you have any queries, you may ask now. We will discuss.